Welcome to the video tutorials of Mekanismuller. Since the early ages of four-stroke internal combustion engines, there have been numerous attempts to replace them. One of the well-known candidates was the Wankel rotary engine. Since it is not widely used, we may not consider it as a successful competitor to the four-stroke piston engine. The opposed piston-opposed cylinder engine, also known as APOC engine, is another candidate backed by Bill Gates. This engine is under development by Echo Motors, and also backed by Navistar, whose affiliates produce international brand commercial and military trucks. Only time will tell whether it will be a viable alternative to four-stroke internal combustion engines or not. The APOC engine is comprised of two opposing cylinders per module, with a crankshaft between them. Each cylinder has two pistons moving in opposite directions. This innovative design configuration eliminates the cylinder head and valve train components of conventional engines, offering an efficient, compact, and simple core engine structure. The result is an engine family that is lighter, more efficient, and economical, with lower exhaust emissions. The APOC engine has 50% fewer parts than a conventional engine, and uses conventional components, materials, and processes. This animation shows the side and top views of the APOC engine with all major components. This makes the animation of the engine a little bit cluttered, but gives a good overall picture of the workings of the APOC engine. In the video released previously, the major components were shown individually. At the end of the compression, fuel is injected into the combustion chamber. After the ignition, the inner piston arms work in push phase while the longer outer arms work in pull phase. These push and pull actions acting on the crankshaft balances the forces acting on it. Since there are two pistons in a cylinder, the stroke of each piston is shorter. Shorter stroke of piston means higher the rotation speed of the crankshaft. At the end of the expansion phase, the exhaust gates open first to discharge the burnt-out gases. After 30 degrees crank rotation, inlet ports are opened and turbocharged fresh air is pumped into the combustion chamber. This process repeats itself with 180 degrees phase shift at the other cylinder. The inlet and exhaust gas movements are emphasized by arrows. The blue arrows indicate turbocharged inlet air while the red arrows indicate exhaust gases. We encourage you to subscribe to our channel and give a thumb up to this video. Thank you.